Hello friends, let us solve a problem on bearing capacity if your water table is in zone 2. First, understand the problem. So, a 3 meter wide square footing is located at a depth of 1.5 meter. Determine the ultimate bearing capacity if water table is 1 meter below the level of foundation. Okay, C is given as 0. For phi equal to 40, NQ is given, and gamma is given. Saturated weight is given. Dry unit weight is given. I think if you see with respect to the previous video problem, so what is the changes here? Only one change is occurred. What is it? In the previous case, if you see, your water table is 4 meter below the level of foundation, but here your water table is 1 meter below the level of foundation. Let us represent that. So here this is the diagrammatically I have already represented the foundation. Now where is your water table? Your water table is 1 meter below the level of foundation. Foundation is 3 meter from this. Where is your water table? It will be somewhere here. So 1 meter below. So from here to here, what is the distance? 1 meter. From here to here, what is the total depth? 3 meter. That means from here to here, how much? 2 meter. So if your water table is in zone 2, which one will affect? The width term will affect, but the depth term will remain the constant. So in this portion, we have to consider the dry weight. In this portion, we have to consider the submerged weight. That's it. Everything will be remain same. So first write the bearing capacity equation, ultimate bearing capacity equation, that will be equal to, as C equal to 0, I am not representing that, gamma D into NQ plus, what is the shape factor for square footing? 0.8 into 1 by 2. Gamma B N gamma, right? First I'll write down the gamma value. Gamma. So what about, for this I will write it as N gamma. So that will be feasible. So if I write it down N gamma, what are the remaining terms? Gamma into B. Is it under completely dry condition? No. Some part is under dry, some part is under submerged condition. So what is the dry mass distance? Depth 1 meter. So B into, sorry, what is the B? Gamma, isn't it? Gamma into, up to how much depth it is under dry condition? 1. After that it is under submerged. How much? Gamma dash. Up to how much distance? Depth 2. That's it. Substitute the parameter. Gamma is given as how much? 20. D is given as 1.5. NQ is given as 82. Plus 0.8 by 2. That means 0.4 into, what is the N gamma value? 100 into gamma, that means 20 into 1. 20 into 1 plus gamma dash is how much? Gamma dash is nothing but a gamma saturation minus gamma W. Gamma saturation is given as how much? 24. 24 minus 9.81. How much you are getting? Submerged unit weight. That will be equal to 14.19 kilonewton per meter cube. Substitute that value here. 14.19 into 2. Now do the calculation and tell me how much you are getting here. 20 into 1.5 into 82 plus 0.4 into 100 into 20 plus 14.19 into 2. You are getting around 4395 ultimate bearing capacity, that will be equal to 4395.2 kilonewton per meter square. Thank you.